Have you ever wondered what keeps our digital world from just falling apart? Seriously, today we're going to dive into the hidden rules that stop our databases from turning into total chaos, especially when everyone wants the exact same thing at the exact same time. Okay, picture this. There's only one spoonful of chocolate spread left in the jar, and suddenly everyone makes a run for it. It's absolute pandemonium, right? Well, believe it or not, that's pretty much what happens inside a computer database all the time. It's called a race condition, and without some serious rules, it leads to a complete mess, corrupted data, and digital disaster.
So how do we stop this data catastrophe from happening? Well, it all starts with a couple of fundamental ground rules. You got to understand these two principles, because they are the bedrock that makes everything else work.
Okay, rule number one is the transaction. Think of it like you're building a tower of blocks. If you go to place the fourth block and the whole thing starts to wobble, you don't just walk away leaving it half-built and ready to collapse, right? No, you start over. It's the same in a database. Either every single step of an operation succeeds perfectly, or the whole thing gets rolled back like it never even happened. It is all or nothing.
And our second big rule is isolation. This is like giving everyone their own private bubble to work in. What I'm doing over here shouldn't mess with what you're doing over there until my action is totally and completely finished. Isolation is absolutely crucial because it makes sure that all these things happening at once don't trip over each other and scramble the data.
All right, now that we've got our rules down, let's meet the villains of the story. These are the three, let's call them pesky glitches that can pop up and cause mayhem if our isolation rules aren't strong enough.
First up, we have the dirty read. So imagine I'm trying to buy the very last TV in stock. The system marks it as sold while my payment is still spinning. A lemming comes along, sees it's sold, gets bummed out, and leaves. But then, whoops, my payment fails. The whole transaction gets canceled and that TV is actually available again. See the problem? The lemming acted on unconfirmed or dirty information and missed out. For a business, that's a lost sale, all because of bad data.
Then we've got this one, the non-repeatable read. A lemming is browsing and sees a fish for $5. While they're thinking about it, I'm in the back-end system and I update the price to $10. The lemming looks again a second later and, wait, what? The price just changed? The data they read the first time couldn't be repeated, which causes all sorts of confusion and can really mess up things like financial reports.
And last but not least, we have the spookiest glitch of them all, the phantom read. Okay, so a lemming carefully counts 1, 2, 3 jars of chocolate spread on the shelf. While they're not looking, I sneak in from the stockroom and add a 4th jar. The lemming double-checks their count and, suddenly, there are 4. It's like a phantom jar just appeared out of thin air. This kind of thing happens when new data gets added that matches what you're looking for, creating these ghost-like inconsistencies.
So how in the world do we fight off these data glitches? Well, databases give us what you can think of as a ladder of solutions. And with each rung we climb up this ladder, we get a stronger level of defense, a higher, better degree of isolation.
Right at the very bottom, on the first rung, we have read uncommitted. This is the loosest, fastest, and honestly, the most chaotic level you can have. You can pretty much think of it as the Wild West of databases.
I mean, this level is blazing fast, but it gives you almost zero protection. It's totally vulnerable to dirty reads, non-repeatable reads, and phantom reads. Everybody can see everyone else's messy, half-finished work. It's pure chaos, and you almost never use it for anything where you need the data to be trustworthy.
All right, let's take one step up the ladder. This brings us to read committed. Now this level starts to bring some much-needed order to the chaos, and it's actually the default setting for a lot of very popular databases out there. Read committed is our first real line of defense. It completely solves the dirty read problem. How? It makes sure that transactions can only see data that's been permanently saved, or committed. So now, that lemming wouldn't see the TV as sold until my payment actually went through. It's a huge improvement, but prices can still change and those phantom jars can still appear. Let's keep climbing. The next rung up is called repeatable read. And, just like the name suggests, this level gives you an even more stable and consistent view of the world while you're working.
With repeatable read, we've now solved that annoying non-repeatable read glitch. What happens is the database essentially takes a snapshot of the data the moment our lemming starts shopping. That $5 fish is going to stay a $5 fish for their entire visit, no matter what I do in the background. It gives you great consistency for rows you've already seen, but that phantom jar can still sneak onto the shelf.
And now, here we are. We've made it to the very top of the ladder. This is the highest level of protection you can get. It's called serializable. Think of this as maximum security for your data.
Serializable solves everything. It's like forcing everyone to get into a single file line. Each person's task has to finish completely, one after the other, with zero overlap. It makes it physically impossible for transactions to interfere with each other, so it gets rid of all three glitches. But as you can probably guess, forcing everyone into one line creates a massive traffic jam. It is the absolute safest, but it is also, by far, the slowest.
And this brings us to the absolute heart of the matter, what this is all about, the great trade-off. Because climbing this ladder of safety, well, it isn't free. Every single step up you take in data integrity comes at a cost, and that cost is performance.
This table here lays it all out, clear as day. As you move down the list and consistency goes up, performance goes down. It's a direct trade-off. And this forces engineers to make a really critical choice. Do you need your data to be perfectly 100% correct, or do you need your application to be lightning fast? You can't always have both.
And that right there is the key takeaway for all of this. There is no single best isolation level. It just doesn't exist. Choosing one is a huge engineering decision. It's all about deeply understanding what your application needs and then finding that perfect balance between keeping your data safe and keeping your app fast for your users.
So I'll just leave you with this thought. Think about the apps you use every single day. Your banking app. You can bet that's using a super high isolation level. You need those numbers to be perfect. But your social media feed, seeing a like count that's a few seconds out of date so the feed loads faster is probably a trade-off we can all live with. So the question is, what choices are being made with your data right at this very moment? It's a pretty fascinating thing to think about. Thanks for tuning in.